In this video, we are going to give a short introduction to the non-Euclidean geometry. But before discussing the non-Euclidean geometry, let us see what a Euclidean geometry is. So Euclidean geometry is the one which we all have studied in our school. So it is the study of a flat space or a plane surface. It was studied by Greeks extensively, but it was systematically developed by Euclid in around 300 BC. He wrote 13 volumes of a book called The Elements, and in the first volume he introduced few terms, geometric terms such as point, line, angles and so on, and he also introduced 5 postulates, 5 axioms of geometry. So the axioms are that a straight line you can always draw from a point to any other point, and any finite line, any finite straight line can be extended continuously to a straight line. Given a point and given a radius, you can always draw a circle. And fourth postulate says that all the right angles are equal no matter how you draw them. And the last postulate says that if you take two straight lines and you cut these two straight lines by another line, which make interior angles alpha and beta, such that the sum of these angles is less than 180 degree, then you can always extend these two straight lines to meet at a single point on the side where these angles make the sum less than 180 degree. Now this fifth postulate troubled many geometers for a long time. For around 2000 years, they were troubled by the complexity of the fifth postulate, and they believed that they can deduce it using the first 4 postulates. In fact, many mathematicians tried to prove the fifth postulate by a contradiction, but they could only reach to a equivalent statement. For example, in 1700, Wallis proved that the sum of the angles of any triangle is 180 degree, which is equivalent to the fifth postulate. And in 1795, Playfair proved that if you have a straight line and a point not lying on that line, then you can always draw a line through that point which is parallel to the given line, and this postulate is known as the parallel postulate. So non-Euclidean geometry is the study of geometry which contains the postulate which is equivalent to the negation of the Euclidean parallel postulate. So there are 2 important non-Euclidean geometries. One is the spherical and the other is hyperbolic geometry. In spherical geometry, we assume that if you have a line and a point not lying on that line, then any line through that point intersects the given line. So you cannot find a line parallel to it. And in hyperbolic geometry, we assume that we can find at least 2 lines through that point not intersecting at given line. So we can find at least 2 lines which are parallel to the given line. And one might wonder that what are the applications, because we have already we just studied the Euclidean geometry during our school time, but it has some very nice applications. So according to Einstein's general theory of relativity, the universe obeys the rules of the geometry, not that of Euclid. So the space is curved. Hyperbolic geometry has applications to certain areas of sciences such as the orbit prediction of objects within intense gravitational fields, space travel and astronomy. And spherical geometry actually describes the surface of a sphere in our earth better. So whenever you travel by plane or a ship, the geometry which the pilots and the captains use to navigate around the world is the spherical geometry, not the Euclidean geometry. Let us quickly see what a spherical geometry is. So the spherical geometry is the study of the curved surfaces like this sphere and the ellipsoid. It was developed by the German mathematician Riemann in 1889, who actually rediscovered the work of an Italian mathematician which shows certain flaws in the Euclidean geometry. So let us try to understand it a little better. So just try to just think about a sphere, a globe, and then you can visualize that the sum of these angles of a triangle is greater than 180 degree. Why? Because you can see that the surface is basically bulging out, it's not flat. Also, you can easily visualize that the perpendiculars to a straight line meet at one point, and lines always intersect at 2 points, not just one. Given a line and a point not on it, there is no line passing through the given point which is parallel to a given line, which actually negates the parallel postulate. Similarly, the hyperbolic geometry is the study of such kind of objects. So these are the crochet models of hyperbolic geometry, and these are the references from where the content is being taken and the graphics are taken. So thanks